Hi, my name is Aurelius Rains, and I'm here to teach Coding Club. And today I'm going to be doing some more training about different types of electronics and technology. Today we're going to do an electronics lesson. We'll teach you guys about how simple circuits work, and then we're going to go ahead and build a circuit. I think that in a future class, what I'm going to do is show you how to go ahead and get all the parts you need to do this kind of thing from like a Family Dollar or Dollar Tree store. Um, so I think one of the coolest things to be able to do is to be able to hack your environment and take all the supplies you need from the things around you and just have an attitude that there's no such thing as trash, right? Everything can be reused for another purpose. Of course, that might make your living space kind of junky, but that's a whole nother issue. So today we're going to work on learning about a circuit and how a circuit works, okay? So let's go ahead and let's get started. So let's have a look at a simulation here. We're going to do it in a simulation first, and then once we get from the simulation, we can go ahead and I can show you how to do it in real life. This is FET simulations, by the way. They make these virtual labs where you can go ahead and experiment and play around with electronics online without ever having to actually buy the stuff. So you can go ahead and simulate how electronics work. All right, so what I want to do right now is I want to make a very simple light circuit. Okay, I'm just looking at all the things that I have here. I have a coin, a eraser, a dog, a pencil, wire, dollar bill, a fuse, a battery, which is important, right? Another battery, a light bulb. Okay, so I have everything I need. All right, so I want to show you how a circuit works. A circuit is basically the word circuit comes from the word circle. And circuits is about making a very simple to very complex circles that allow electricity to go from the positive end of a battery to a negative end of a battery. So first of all, let's go ahead and let's talk about batteries. So here we have a generic battery that is, I guess, designed to look like a Duracell. Shh, don't tell nobody I said that, right? And I'm pretty sure most of you guys, if you have a TV remote or if you ever had to put one in a game controller before, you know what a battery looks like. You can get them anywhere. They don't cost a whole lot of money. You get them at the Dollar Tree for not a whole lot of money. And let's break down this battery. This battery has two sides. One, you'll see that there's a little nub here on one side, and the other side is flat. The little nub here on this side is actually the positive end of the battery. Okay. And this part right here is the negative end of the battery. And the secret to a circuit is making the positive end somehow get connected to the negative end. Now, how you're going to do that with a straight line, I'm going to show you, okay, in just a second. Most batteries that you buy in the store only have about 1.5 volts. That means that they're actually are designed to, let's turn this off, show current for now. That means the battery is designed to only have 1.5 volts. And just a little word about electricity. 1.5 volts is not enough to electrocute you. You know those little rectangular batteries, like those little rectangular shaped batteries? Those are 9-volt batteries. A 9-volt battery is not enough to electrocute you. You can touch both ends, you won't feel a thing. Even a 12-volt battery, you really won't feel much. You really have to get up to like maybe 20 volts before you start to feel like a little buzz just by touching it with your fingers, because your skin is a very good resistor. It sort of stops electricity from shocking you. It's only when you have very high voltages that doesn't make a difference. And again, you can learn more about that, but I just want to assure you that, you know, playing with batteries is a relatively safe thing to do. You're not going to find yourself in a position where you're going to electrocute yourself. Just be careful about connecting the positive end to the negative end, and not having anything in between, because the battery will start to get a little hot on you. Okay, so let's go ahead and let's see exactly how many volts this battery is. This is what's called a voltmeter. And if I stick one end to the positive side and I stick the other one to the negative side, it will tell me that this is a 9-volt battery. Okay, I do not want this battery to be 9 volts. I want this battery to be 1.5 volts. So I'm going to go ahead and turn it down to just 1.5 volts. That is the standard voltage of a battery. Okay, that's good to know. I'm glad I checked it first before I start doing experiments. Otherwise, I would have had some blown out parts. Okay, all right, so this battery is 1.5 volts. Okay, now of course you don't have to be like a super math whiz to know that if I take this battery and this battery and put them together, how many volts is that going to be? Well, assuming that this one is 1.5 volts too, which it should be. Can I just type it in? No, I got to do it the hard way. Okay, fine. All right, so both these batteries are 1.5 volts. So if both these batteries are 1.5 volts, that means 1.5 plus 1.5 is 3 volts, okay? Just a nice little thing to know. I'm going to just go ahead and put this to the side for now, okay? And let's just go ahead and get our circuit going. So what I'm going to do is I'm going to get a light bulb, okay? And you'll notice our light bulb has two sides too. This part right here is the ground, or the positive side, and this part right here is the ground or the negative side, okay? And the thing is, you want to stick the positive to the positive and the negative to the negative, okay? Now, light bulbs don't necessarily have a positive and negative side. We will be working with some lights later on in this lesson that do have a positive and negative side, okay? Now, what I'm going to do is I'm going to get a wire, okay? And I'm going to connect the positive side from the positive side of the battery to one side of this battery, or the light bulb right here. Then we get another wire and go from the negative side of the battery to the other terminal on the light bulb, all right? And you see the light actually comes on, all right? Of course, as a simulation is making a little dim part. Let's do this. Let's go ahead and let's make this as if it were two batteries together. We said that two batteries together, two 1.5 batteries together, it's going to be 3 volts. Let's go ahead and let's make this 3 volts. And you see, as the voltage goes up, the battery gets brighter, right? The more volts I give, the battery, the brighter, the brighter the light gets. In this case, I'm giving 20 volts. That's 120 volts, and it's a very, very bright bulb. Now, this is an incandescent bulb, and you can go ahead and put a lot of electricity through an incandescent bulb before it blows out. But you do have to be careful in real life how much battery or how much electricity you put through an incandescent bulb, because they will blow out on you, okay? And the other thing about incandescent bulbs is that it doesn't really make a difference which order you put it in. So here I can go ahead and switch to positive and negative, and when I do it, it still lights up, okay? And we're going to find out that for some other types of lights that may not be the case, okay? So what's actually happening here is I'm going to go ahead and show this electron moving now. You can see the electrons are moving, okay, from the positive end through the negative end, through the light, and back down again, all right? This is a running circuit. If I go ahead and I disconnect that circuit, the electrons stop. If I go ahead and connect it again, they start running, and that's how electricity works. Very simple in a nutshell, okay? So let's go ahead and let's do this in the real world. So let you look down at my desk, and here's my desk view. And if I look down at the desk view, I'm going to get some components that I need. Of course, we talked about the batteries, so here are 2 AA batteries. That shadow out the way a little bit. There we go. Here are 2 AA batteries. Here's a battery holder. Again, you'll see the parts I was talking about. The little nub on the end, that's the positive side, and this part is negative. Again, if you ever get confused, you actually see the little markings on the side that say negative and positive. I'm not sure if I can hold that up. Does it get out of focus? Yeah, it doesn't quite focus on that at that level. But yeah, it's positive and negative again, but the best way to tell is the positive end has a nub and the negative end is flat, okay? So I'm going to do the same thing. If I look inside of my battery container, I'll see a little shape or picture of a battery that shows the nub, so it tells me where to put it in. So usually the flat side goes against the spring. I just push that in right there, all right? And again, I push this in, flat side, boom, and there. And now what I've done is I've created a battery pack that I can use to do experience. And again, if I touch the battery pack, nothing happens. If I touch them at the same time with the same finger, nothing happens. 3 volts cannot shock or hurt a human being. Okay, we're just too big for that. All right, for 3 volts. Now, if I were an ant, it'd be a totally different story, right? Don't ask me how I know that. I'm a science teacher. I know a lot about biology. Okay, so here we go. Once I do that, now I'm going to go ahead and I'm going to set up a light. Okay, let's use a green light for now. And what I'm going to do is I'm going to connect positive and negative. All right. So we're going to talk a little bit about the positive and negative of a. We're talking about the positive and negative of a LED, and this is an LED. It's a very low powered light, and it can work just on 3 volts. Okay, but I'm going to connect this stick right here to those clamps. I'm going to take another clamp. I'm going to connect one clamp to here and another clamp to there, and boom, we have a light. Okay, if I go ahead and shut off this, you can see that I have a light here. Okay, that is a very, very simple circuit. All right, let me disconnect. All right, I could do it with any color. I'm going to let's try it with the green one here. All right, and connect that one there to that post. Okay, and by the way, this one does have polarities. This long part is positive and this short part is negative, and boom, now I've got a green light. Okay, these batteries are extra fresh. All right, let's try it with this light right here. I got to be careful though, because I've like really hurt myself because these lights are extra bright. And one day I was working with these lights, building a circuit, building a light board, and I just had spots in front of my eyes for the next couple of days. It was pretty bad. So always want to be careful. So let me turn the light back on so I could see which side is positive and which side is negative. It's really, really small writing on here, but yeah, okay. That's positive. Boom. And that's negative. Okay, I'm going to look away. Okay. You can see how bright that is. All right. I'm not going to look directly at that. I learned my lesson. Okay. That's a very, very bright light. All right. It can light up the whole board just by itself. Okay. Great. Wonderful. Now, that's how that works. Okay. That's a very basic circuit. It's very easy to build. A lot of the parts that you use from this, that I used here, you can go ahead and get parts from the Dollar Tree, and maybe for the price of $3 maximum, you can have the LED, you can have the battery, and you might even be able to find some paper clips or something like that to use as wires, because you can use paper clips as low-key wires. You know those little garden lights that they have at Dollar Tree, where they have like maybe sometimes they're B-shaped, sometimes they come up for the holidays, or like they might be shaped like a flower or shaped like a bat for Halloween or whatever. Those little lawn lights that you get at Dollar Tree, they usually have them right in front of the store. Those things cost $1 a piece. You can take those home, break them open. Inside you're gonna have an LED light. You're gonna get a little small photovoltaic or a solar panel and a rechargeable battery, and just take it apart and do experiments with that. And again, you can't hurt yourself. All right, you really can't hurt yourself unless you're trying really hard to, in which case I can't do nothing for you. All right, so we noticed that I was able to go ahead and create a very basic light. But how do I control that light? That's a great question, right? How do I turn it on and off without any drama? And the way you control this light, the way you turn it on and off without drama, is by putting in an element called a switch. This is a switch. And what a switch does is it controls when the circuit moves and when it doesn't. So if I connect this to my positive part and connect this to the other end of the switch, right? Now what happens is I can control when the electrons move and when they don't. If I just go ahead and click this part right here, if I pull the switch down, things start to move. If I push it back up, things stop moving. On, off, off. And this is exactly how the light switch in your house works, okay? There's a little metal part inside of that switch. When you go ahead and flip it down, it disconnects the wires on the inside of there so that the circuitry of the light in your room does not connect. And then once you go ahead and flip the switch back up, it reconnects those circuits so that you can go ahead and start getting light, okay? Off, on, off, on, off, on. And of course, no, the switch isn't magic. If I just go ahead and put 2 switches in here, then I can go ahead and create maybe a fail safe to make sure that I'm double sure I want to turn this on. So if I click that on, nothing happens. I still have to go ahead and click the other switch in order to make sure that the electricity flows, all right? So that's pretty cool, right? So I'm going to go ahead and I'm going to try and I'm going to actually go ahead and add a switch to my circuit down here on the desk. All right, so let's turn the light back on and let's just get back to our desk view and see if we can go ahead and add a similar type of switch. Okay, so again, I got my little light here. Let's use my little green one. Okay, I've got a positive connection here. So let's go ahead and let me open up the Alligator Clips and connect them together. Okay. Oh my gosh, I'm having a hard time there. There we go. Okay. So now I got the positive connected, and now I'm going to connect my negative. But now, instead of connecting the negative directly to here, what I'm going to do is I'm going to run it through my switch. So I'm going to just go ahead, I'm going to clip on to one side of this. So you see that on the switch, there are 2 tongs, right? And what I'm going to do is I'm going to go to attach to one side of those tongs. Boom. Okay. And then I'm going to get another one of these little clips. I'm going to attach to the other side of the tong. And I'm going to make sure that the 2 little clips are not touching. Okay. There, you see? And if you look up close, you'll see that they're not actually touching each other. They're just clipping onto the 2 little sides there, right? And now I'm finally going to take this other part and clip it to my light. Boom. Now, when I push the button, the light comes on. That's my switch. Okay? Now, of course, I've been showing a light the whole time. It doesn't just work with lights. If instead of using a light, I want to use, so instead of making light, I wanted to make sound. This is a buzzer, okay? These I actually did buy from a place called American Science and Surplus. So if you live in Chicago, there's a store on the north side of Milwaukee called American Science and Surplus, and they just have all these really great electronic parts. So if you want to fiddle around, if you want to make rockets, if you want to get cool model building projects, they have all that stuff up there. Somebody told me about the store years ago, and I just not believe it was that cool. It sounded boring. American Science and Surplus is the boring name for a store. That is the most awesome store, especially if you like to build things and tinker. So what I'm going to do here is I'm going to, again, I'm going to add positive here, one end to the positive, and I'm going to add one end to the negative. Okay, and nothing, but you'll notice that when I hit the button, I get a little beep. See, I can do Morse code. For anybody who doesn't know, that's Morse code for SOS. I need help. Which is pretty cool. And let's say instead of doing light or sound, I want to do motion. Okay, this is a motor. Okay, a motor is just a mechanism that helps things go, that helps things move. I put a little piece of flag on the end here, and the flag will let us know that it's spinning, because it's sort of hard to see the axle of the motor spinning if there's nothing attached to it, okay? So it also has a positive and a negative, and depending on which way you connect it, depends on which way the motor spins. If I were to open this up and look on the inside, there's some copper coil and a magnet, and once you run electricity through the copper coil, it becomes magnetized, and it pushes against the magnet and repel and attract motion alternately, and it makes it spin around. So enough of that physics. Just go ahead and let's connect it and see what happens. That's black, and that is the red one. Okay, now they're connected, and then when I hit the button, it should spin. It is not spinning. Let's see, everything connected? It's not spinning at all. Why am I being clowned? Is something touching that shouldn't be touching? Maybe this motor is broken. Let's go ahead and let's take the switch out of there and just see if I can manipulate it and get it to work. So now I have a full connection. Oh, there we go. Now it's spinning. Okay, so let's try it again with the switch. Okay, there we go. I think maybe I might have had a cross wire somewhere. That's probably what's happening. And now it spins. Okay. I'm pretty sure most of you guys you either have a cell phone or you know somebody who does. You use a cell phone, and that cell phone's going to vibrate mode. This is what allows your cell phone to go into vibrate mode, maybe a smaller version of this. This is what's called a vibrating motor. And vibrating motor do exactly what they sound like they do. They vibrate. So if I go ahead and I connect this one right there, and I connect this one to this end. Uh-oh, wait. Where's the other end? Oh, there it is. Connect this to this end. I can actually make the motor vibrate. Let's see here. Oh, fell off. Okay, let's see here. There we go. Oh, it shook itself off. That's a great thing about vibrating motors. You got to make sure the connections are nice and sturdy because they vibrate. It's the same thing as a regular motor, except the little turning part has like a weight on it that's not balanced. So it's not totally symmetrical. And since it's not balanced or symmetrical, that means that it wobbles when it spins. And I'm not sure if you guys here know that, but yeah, whenever you have something spinning at a fast rate or you're in a slow rate, it wobbles. Let me get some more of that out. I'm going to just cut off a little bit more of that, because what I want to do is I want to get the metal part exposed. The metal part is what we call the conductor, and it's the part that actually, well, conducts electricity. The metal part's not exposed. If you have plastic on plastic, plastic does not conduct electricity, but metal does. And these wires are so fine and so delicate, it's hard to make sure you get the metal parts connected. There we go. It's vibrating. What's really fun to do is connect these to like a bottle and then create the circuit, and then the bottle starts to shake, and then it just starts to move around. You put googly eyes on it, and that's usually like one of the first types of robots. Or you can get an old toothbrush, put one of these on an old toothbrush. Use these right here, these little dime. Again, you get these at the dollar store. These are 3 volts by themselves, and so what you do is you just stack it on with a little tape, and you connect it over here, and then you put it on top of a toothbrush, and you make what's called a bristle bot or a bug bot. Go ahead and make it like a roach on the top, and then set it free in your mom's room and watch her freak all the way out. I didn't tell you to do that. That's a horrible thing to do. Don't ever do that. Okay. All right. So that is how you make a basic circuit with a switch. Okay. So now that I've shown you that, what I want to show you is, you've noticed the difficulty I've had using these little alligator clips, right? And alligator clips are a great way of doing really quick, fast, in a hurry circuits. These are the tools that I use whenever I'm teaching kids how to make their first circuits. I use the alligator clips. If you have, good dexterity with your fingers, they're relatively easy to use. But what I want to do is I want to use a breadboard. Now, this is a breadboard. And a breadboard is a great way for prototyping or putting together circuits and not having such a hard time like sticking them to other parts, okay? And I'm going to show you basically how a breadboard works. So you'll notice that on this breadboard there are a lot of holes, okay? As a matter of fact, let's go ahead and let's pull up a breadboard in our circuits catalog. All right, so let's switch over to our screen instruction. Boom. All right, so right here I'm going to pull out a breadboard. Okay, and you will notice, hold on, let's not do that just yet. All right, you will notice that the breadboard has a series of holes. Okay, you'll also notice that the breadboard has some letters across the top and then numbers down here. Each one of these holes is connected in a special way. And you'll notice that as I go over the holes in the middle, right, that the entire rows are connected together. So imagine that I have a little wire under here, right, in row 5, and it connects every single hole in row 5. So whatever I do to over here in F5, the same thing's going to happen over here in J5. All right. But on this side, on the side rails, I got this positive and negative. And what that means is that this entire column is connected together, as well as this entire column is connected together. So what I can do is, if I go ahead and if I stick a battery, and I'm going to use a coin cell battery like the one I showed you earlier. Again, if you look right here, this is a coin cell battery, okay, that I put together, that I bought again at the Dollar Tree. Make sure you take the sticker off, by the way, before you start trying to experiment with it. All right, so that's the coin cell, and so this is the battery holder that it goes into. So you just take the coin cell and you put it inside the battery holder, and again, you should be removing the sticker first. I'm just not doing it because I want to save this battery for another project that I'm doing later. Okay, you put it inside of this little holder. All right, and now I can use it in order to build circuits. All right, so same thing here. I'm going to go ahead and have my battery here, and again, you see I have a positive side and a negative side. Okay, I'm going to stick the positive side into the positive hole. Boom, make that connection. Okay, and then I'm going to stick the negative side into the negative hole. Boom, make that connection. Okay, all right, so that means now I have electricity actually going into this rail. If I get one of my little LED lights and I connect the positive end of my LED here and the negative end of my LED here, okay. Oh wait, did I actually connect it? Is it connected? Nah, that doesn't look clean. Let me undo it. Oh no, it's connected. It's fine. Okay, so I got it in there, right? Now when I hit play, it should light up, assuming that I did it right. Start simulation, and my light runs, lights up. I'm getting a current through the LED is 61 milliamps, while recommended maximum is 20. The usable lifetime of the LED may be reduced, right? So yeah, so whenever you're using an LED, what you really should do is use a resistor. We haven't talked about resistors. Here's a resistor right here. And what a resistor does is it slows down the electricity. So I'll go back to my other simulation, right? Let's take this out for now. Let's get rid of that, okay? And let's put in a resistor, okay? So what I want to do is first, I want you to go ahead, I want you to see what it looks like without the resistor. I want you to see how fast the electrons are moving without the resistor, okay? And then I want you to watch what happens when I put the resistor in there. I'm going to just cut here, put in a resistor here, and then connect the other end here. Now there's a resistor in there. And you notice that the electrons move a lot slower, right? The electrons move a lot slower. If I duplicate this, circuit without the resistor, you'll see the difference. So same circuit without the resistor. Okay, and what did I put this on? How big is this battery? It's 10 volts, right? I'm going to make this one 10 volts too. Okay, so you see both batteries are both 10 volts, right? But the electrons are moving a lot slower than this battery than they are through this battery because the resistor slows it down. But you also notice that with the resistor, the light is dimmer, right? So you will get a dimmer light, but it also helps to control the electricity. And the resistors help to control electricity, make sure the electricity does not get out of hand. All right, so let's go back to our circuit here. And let's say if I just go ahead and stick a resistor in this circuit. So what I'm going to do is I'm going to always forget how to disc it. There we go. And I'm going to stick one end through there, and then I'm going to create another connection from this end into the negative part. Boom. All right, and now when I start the simulation, my light is on, and you notice that it is a bit dimmer, but you also notice there's an exclamation point telling me if there's a problem. So electricity is going from the positive end, right, through this rail, through the LED, through the resistor, which is slowing everything down, back to the negative end, back to the negative end of the battery. All right, and that is how a circuit works with a resistor. Okay, I can take this out. Let's see, I can take this end out. And if I take the actual battery out and remove it to the trash here, get rid of that, right? I can put in a 1.5 volt battery, but I'm going to make it 2 batteries. So now it's 3.5 volts. And just like I did before, negative and negative, positive and positive. And hit start simulation, and my light comes on. Okay, all right, and that's very simply how you build a circuit. So I would love to talk to you more about that. I do teach these things in the coding club. You have the ability to work with computers, to work with programming, to learn cybersecurity, aka hacking, to learn electronics, to learn fundamental robotics, to learn a bunch of different things. And on top of that, you also get a microbit, and a microbit is a great kit that you can use in order to go ahead and, oh wow, I forgot that I have my green screen on. All right, so the microbit is a great little tool you can use. You can program in order to do all types of really cool tricks, including program when the light goes on based on things going on in the room. So you can actually make it so that when I turn the lights off in the room, that the LED will automatically come on. So you can actually program your own night light, which is really easy to do and kind of fun too. All right. I want to thank you all for spending this time with me. Again, I encourage you to reach out to Dean Brown if you are interested in joining the Coding Club. The Coding Club is a club where I teach you how to do whatever you want to learn how to do as it pertains to electronics, computer programming, and robotics. If there's something you want to learn how to do that I'm not talking about, I can probably help you learn how to do it. Be sure to hit me up, right? I hope you enjoyed this video. Go ahead and subscribe so you can find out when my next video comes out. I usually drop them every Monday and Wednesday. And I want you to have a nice day. Bye-bye.